Welcome to this presentation. In this presentation, we are going to see about the CSMA, that is Carrier Sense Multiple Access. In random access or contention methods, no station is superior to another station and none is assigned to control over another. No station permits or doesn't permit another stations to send. At each instance, a station that has data to send uses a procedure defined by the protocol to make a decision on whether or not to send. So, to minimize the chance of collision and therefore increase the performance, the CSMA method was developed. The chance of collision can be reduced if a station senses the medium before trying to use it. The CSMA requires that each station first listen to the medium or check the status of the medium before sending. In other words, you can say that CSMA is based on the principle sense before transmit or listen before talk. CSMA can reduce the possibility of collision, but it cannot eliminate it. The reason for this that you can see in this diagram, right? In this diagram, so the reason for this is a space and time model of a CSMA network is shown here. So stations are connected to a shared channel, usually a dedicated medium. The possibility of collision still exists because of propagation delay. When a station sends a frame, it still takes time for the first bit to reach every station and for every station to sense it. In other words, a station may sense the medium and find it idle only because the first bit sent by another station has not yet been received. For example, in this diagram, at time t1, station B senses the medium and finds it idle, so it sends a frame. At time t2, which is greater than t1, that is t2 is greater than t1, station C senses the medium and finds it idle because at this time the first bits from station B have not reached station C. Station C also sends a frame. The two signals collide and both frames are destroyed. The vulnerable time for CSMA is the propagation time TP. This is the time needed for a signal to propagate from one end of the medium to the other. When a station sends a frame and any other station tries to send a frame during this time, a collision will result. But if the first bit of the frame reaches the end of the medium, every station will already have heard the bit and will refrain from sending. So in this case, the leftmost station A sends a frame after time at time t1 and which reaches the rightmost station D at time t1 plus tp. So this gray area shown in this diagram is the vulnerable area in time and space. What should a station do if the channel is busy? So and what should a station do if the channel is idle? So three methods have been devised to answer these questions. One is the one persistent method, non-persistent method and p-persistent method. Let us see one by one. So this diagram shows all the three methods. The one persistent method is so simple and straightforward. In this method, after the station finds the line idle, it sends a frame immediately with probability 1. This method has the higher chance of collision because two or more stations may find the line idle and send their frames immediately. Example of this method is Ethernet uses this method only. Alright. And in the non-persistent method, a station that has a frame to send senses the line, and if the line is idle, it sends immediately. And if the line is not idle, it waits for the random amount of time and then senses the line again. The non-persistent approach reduces the chance of collision because it is unlikely that two or more stations will wait the same amount of time and retry to send simultaneously. However, this method reduces the efficiency of the network because the medium remains idle when there may be stations with frames to send. In p-persistent method, this method is used if the channel has time slots with a slot duration equal to or greater than the maximum propagation time. The P persistent approach combines the advantages of the other two strategies. It reduces the chance of collision and also improves the efficiency. So, in this method, after the station finds the line idle, it follows some of the steps. For example, in first step, with the probability P, the station sends its frame. With the probability Q, that is 1 minus P, the station waits for the beginning of the next time slots and check the line again. If the line is idle, it goes to step 1. If the line is busy, it acts through a collision has occurred and uses the backup procedure. And now let's move on to Csma Cd, that is carrier sends multiple access with collision detection. The Csma method doesn't specify the procedure following a collision. Carrier sends multiple access with collision detection augments the algorithm to handle the collision. And now let's discuss the methods. For example, you can see in this diagram. So in this method, station monitors the medium after it sends a frame to see if the transmission was successful. If so, station is finished. If however there is a collision, the frame is sent again. To better understand the Csma CD, now let us look at the first bits transmitted by the two stations involved in collision. Although each station continues to send bits in the frame until it detects the collision, now we are going to see what happens as the first bits collide. So station A and C are involved in this collision, as you can see in the diagram. At time t1, station A has executed its persistence procedure and starts sending the bits of its frame, right? Then at time t2, as you can see, station C has not yet sent the first bit sent by A. So station C executes its persistence procedure and starts sending it the bits in its frame, which propagates both to the left and to the right. The collision occurs after some time called T2. Station C detects a collision after a time T3 when it receives the first bit of A's frame. So, upper station C immediately aborts transmission. That is after a short time, but we assume immediately, right? Then station A detects collision at time T4 when it receives the first bit of C's frame. It also immediately aborts transmissions. So looking at this figure, we see that A transmits for the duration T4 minus T1 and C transmits for the duration T3 minus T2. And the length of any frame divided by the bitrate in this protocol must be more than either of these duration. At the time T4, the transmission of A's frame, though incomplete, is aborted. At time T3, the transmission of B's frame, though incomplete, is aborted. So we can now see the more complete frame. For example, for Csma CD to work, we need a restriction on the frame size. So before sending the last bit of the frame, the sending station must detect a collision, if any, and abort the transmission. This is so because the station, once the entire frame is sent, doesn't keep the copy of the frame and doesn't monitor the line for collision detection. Therefore, the frame transmission time, that is TFR, must be at least 2 times the maximum propagation time TP. So to understand the reason, let us think about the worst case scenario. If two stations involved in a collision are the maximum distance apart, the signal from the first takes time TP to reach the second, and the effect of the collision takes another time TP to reach the first. So the requirement is that the first station must still be transmitting after 2 TP. And now let us see the flow. It is similar to one of the Aloha protocol, but there are differences. The first difference is the addition of the persistence process. We need to sense the channel, and before we start sending the frame by using one of the persistence process, and the corresponding box can be replaced by one of the persistence process which we have discussed earlier. And the second difference is the frame transmission. So in Aloha, we first transmit the entire frame and then wait for an acknowledgement. In CSMA CD, transmission and collision detection is a continuous process. We do not send the entire frame and then look for collision. The station transmits and receives continuously and simultaneously. And now we use a loop to show that the transmission is continuous process. We constantly monitor in order to detect one of the two collisions. Either transmission is finished or collision is detected, or either even stops transmissions. When we come out of the loop, if the collision has not been detected, it means that the transmission is complete and the entire frame is transmitted. Otherwise, a collision has occurred. And the third difference is the sending a short jamming signal that enforces the collision in case other stations have not yet sensed the collision. And we can say that the level of energy in a channel can have three values, that is 0, normal and abnormal. At the 0 level, the channel is idle. At the normal level, a station has successfully captured the channel and is sending its frame. At the abnormal level, there is a collision and the level of energy is twice the normal level. So a station that has a frame to send or is sending a frame needs to monitor the energy level to determine if the channel is idle, busy or in collision mode. The throughput of the CMA CD is greater than the pure or slotted allowed. The maximum throughput occurs at a different value of G and is based on the persistence method and the value of P in the persistence approach. For one persistent method, the maximum throughput is around 50% when G is 1. For non-persistent method, the maximum throughput can go up 90% when G is between 3 and 8. And now let's move on to Csms Mca. The basic idea behind the Csma CD is that a station needs to be able to receive while transmitting to detect a collision. So when there is no collision, the station receives one signal, that is its own signal. And when there is a collision, the station receives two signals, its own signal and the signal transmitted by second station. So to distinguish between these two cases, the received signal in these two cases must be significantly different. In other words, you can say that the signals from the second station needs to add a significant amount of energy to the one created by the first station. So in a wired network, the received signal has almost the same energy as the sent signal because either the length of the cable is short or there are repeaters that amplify the energy between the sender and receiver. This means that in a collision, the detected energy almost doubles. So in a wireless network, much of the sent energy is lost in transmission and the received signal has very little energy. Therefore, a collision may add only 5 to 10% of the additional energy. So this is not useful for effective collision detection. So we need to avoid collisions on wireless networks because they cannot be detected. So Csma Ca was invented for this network, that is carrier sense multiple access with collision avoidance. So collisions are avoided through the use of Csma Ca using three strategies, that is interframe space, contention window and acknowledgement. Thank you.